Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through all the solutions to the week 10 revision sheet. So let's start at question 1. So we were given the equation x squared minus 5x plus 1 is equal to 0. So when solving this, you should see pretty quickly that you can't factorize this, because if you want to find two numbers that multiply to 1, you've only got 1 and 1 or minus 1 and minus 1, neither of which add to minus 5. So you should see pretty quickly we have to use the quadratic formula. So we start by calculating the discriminant. So it's b squared minus 4 by a by c, which gives you 21. Because the discriminant is positive, there will be two solutions. So those solutions will be x equals minus b plus or minus the square root of the discriminant over 2 times a, and just simplifying that, I get 5 plus or minus the square root of 21 over 2. They are the two solutions. Let's go on to question 2. So in question 2, we're asked to graph 4 functions, 2 parabolas, a circle, and an exponential. So let's start off with the first parabola, y equals x squared plus 7x plus 10. So you should be able to see that a, the number in front of x squared, is positive 1. So because a is greater than 0, it'll be a smiley face. The y-intercept is just the constant term. So 0, 10 is the y-intercept. To find the x-intercept, we take our equation above and let y equal 0. Now, unlike the previous question, this one can be factorized. The two numbers that multiply to 10 and add to 7 are 5 and 2. And so this means that the x-intercepts are minus 2 and minus 5. So they're the two x-intercepts. Now we need to find the turning point. X equals minus b over 2a tells us the equation of the axis of symmetry and also the x-coordinate of the turning point. So x will be minus b over 2 times a minus 3.5. So that's the x-coordinate of the turning point. The y-coordinate, to find that, I simply substitute the x-coordinate into the original equation. I'm now substituting x for a negative, so I need brackets around it. So it'll be x squared plus 7 times x plus 10. Let your calculator do all the work. Should get minus 2.25. So now I'm going to mark all of these features on my graph. So I've got the y-intercept up here at 10. The x-intercepts are at minus 2 and minus 5, and the turning point is minus 3.5 minus 2.25. So I just estimate that point. And because I know that it's a smiley face, I know it's going to come down through the x-intercept, go to the turning point, stop, turn around, go in the other direction up through the y-intercept. Now I need arrows on each end because this parabola goes forever. So this is only correct if I make sure that my axes are labeled. This point here is only 10 if I label it as such. So because the turning point is not a whole number, a point with integers, I should label it because it won't be clear just from looking at the graph what the turning point is. So that's the first one done. I'm going to rub out the working out now and do the second one. So this second one is in turning point formula. So it's going to be the same as y equals x squared with a few transformations applied. So this number here, you should know, means it's gone 2 to the right, and this means it's gone 3 up. What we mean by that is that we move the turning point 2 to the right, 3 up. Instead of being 0, 0, the turning point is just going to be 2, 3. So of course the negative in front means that we have reflected this parabola. So if I want to find the y-intercept, I let x equal 0. So in this case, it's not just going to be 3 because it's not in ax squared plus bx plus c form. If x equals 0, y equals minus x, which is 0 now, minus 2 squared plus 3. So that's minus 4 plus 3, which is minus 1. So what I'm going to do is mark the turning point at 2, 3, which is here. I mark the y-intercept of minus 1. Now I need to use the orientation because it's reflected. Because of this negative, it's going to be a frowny face. So I know it's going to go like this. So if you're struggling to see it, just plot a few more points on. But that is essentially the graph of y equals minus x minus 2 squared plus 3. Once again, put arrows on it. You should label the equation on the graph as well. So I'm going to rub this out and now go through the third graph. So the third graph is x squared plus y squared equals 4. So this isn't a parabola because of this y squared term. You need to be able to recognize x squared plus y squared equals r squared is a circle. Center is the origin, so 0, 0. And remember, this is r squared, so if you square root 4 and get 2, that is the radius. So x squared plus y squared equals 4 is just a circle with center 0, 0 and radius 2. So remember, x squared plus y squared equals r squared, circle, center 0, radius of r. So what I do is I mark the center here, 0, 0. So radius of 2 means it'll go 2 up, 2 across to the right, 2 to the left, and 2 down, okay? So the graph will look like this. I just joined them up. I apologize, it doesn't look like a great circle because of my scale. Sorry, it's really hard to draw on these iPads, but it will just be a circle with radius 2 that looks like that. I'm sure yours will look much more beautiful. All right, let's do the last graph now, which is an exponential. Y equals 2 to the power of minus x plus 2. Now we know this is going to be an exponential because it's got an x in the power. So for exponentials, you can use a table of values if you like. We're going to do this one without a table of values by remembering what the general shape of an exponential is. If you have y equals a to the power of x, remember it starts off really close to the x-axis, then gets really big. And y equals a to the minus x, sort of the opposite. It gets really big and then it gets really small, closer and closer to the x-axis. And obviously this is the one we're using here. So remember, 2 to the power of anything can never equal 0. That's why the asymptote of both of these graphs is y equals 0. It can never equal that. So if this part in red circled can't equal 0, y can't equal 0 minus 2, which is minus 2. So whenever you have a constant term like this, so it's not in the power, that tells you the asymptote. The asymptote of this graph is y equals minus 2. Y can never equal minus 2. It also won't go below that. So let's start by drawing the asymptote. So that y equals minus 2 is an asymptote. It's a no-go zone. My graph cannot hit or go beyond that line. Now, because I know it's this type of graph, I know it's going to get really big over here and then get closer and closer to the asymptote. So if x equals 0, y is equal to 2 to the power of 0, which is 1. Anything to the power of 0 is 1. Minus 2. So 1 minus 2 is minus 1. So the intercept is here at minus 1. So beyond that, it's going to get really big over here, and then it's going to get closer and closer to the asymptote here. So if you're not sure exactly how big it's going to get, we can just plot a few points if you like. So if x is minus 1, 2 to the minus x is 2 to the minus 1, minus 2 is 0. So this one actually does go through the x-intercepts. If x is minus 1, y is 0. If x is minus 2, y is 2, and so on. You can plot as many of these as you like. If x is minus 3, y equals 6, which is up around there. That's probably enough, so it'll just go through like that. So that's what the graph of y equals 2 to the minus x minus 2 will look like. Sorry for my bad drawings, but we'll now move on to the non-graphing questions, starting at question 3. So question 3 was a circle has center origin and goes through the point minus 4, 4. We want to find its equation. So if I have a circle with center origin, it's always has an equation of the form x squared plus y squared equals r squared. All I need to do is find r. So you may wish to draw this, you don't have to, but I'll just draw a picture to show you what's going on. So we have a circle like this, center origin that goes through minus 4, 4. As I said, we just need to find the radius. So the radius is just the distance from the center to any point on the circumference. It's just this line here. So to find that, we can use Pythagoras. We can make this sort of a right-angled triangle. This distance is 4, this distance is 4. So the distance of that is the square root of 4 squared plus 4 squared. So that's just root 32. So the radius is root 32. So that means r squared is root 32 squared, which is 32. So the equation of this circle will just be x squared plus y squared equals r squared, which is 32. How easy is that? Let's now go and do question 4. So question 4 wants us to take the same circle and find out where it intersects with the line y equals x. So y equals x is a line that goes sort of through the origin at 45 degrees, and on this line, the x and y coordinate of each point is the same. So how are we going to find out where it intersects? Well, we know it's going to intersect here and here. So, because I said y equals x is the line on which the y and x coordinates are always the same, I can simply substitute that information here. I'm going to take my equation of the circle and change y to x, because I'm looking for the points on the circle where the x and y coordinates are the same. So x squared plus x squared equals 32. X squared plus x squared is 2x squared. Now, I need to undo things in the opposite order to BODMAS, so I need to divide by 2 first, and then I square root. Now note, when we're square rooting 16, we actually get 2 answers, plus and minus 4. So, we have 2 possible x values, which leads to the 2 points. This one here, x is 4, which means y will also be 4, because x and y have the same value on the line y equals x, and down here x will be minus 4 and y will be minus 4. We've now found the 2 points and done question 4. How easy is that? So let's now go on to question 5. So question 5 is asking, if we started off with y equals 3 to the x and ended up with this equation here, what transformations could we apply to this graph to get this graph? So that's really easy. We just look at what is different about these equations. So firstly, we've taken x and mapped it to negative x. So you should already know, if I go from x to negative x in exponentials, it actually works for any function, but in exponentials, this is a reflection about the y-axis. And you already know this. You know that y equals 3 to the x looks like this, so it goes through intercept of 1. It should have arrows on it as well. But y equals 3 to the minus x is a reflection about the y-axis. Starts big, then gets small. So that's what the graph of y equals 3 to the minus x looks like. So that's what I'm saying here. To go from the red graph to the green graph, we first need to reflect about the y-axis. Now we've also got this 3 here in the power. So this extra number in the power is sort of like h with parabolas. It shifts it left and right, and it shifts it the opposite way that you'd expect. So what the positive 3 does is it goes left 3 units. So it's a shift. The proper name for that is a translation. Okay, so anything in the power, any number in the power shifts the graph, translates it left and right. It goes in the opposite way you'd expect. Positive numbers move it to the left and negative numbers to the right. Now we're already familiar with this transformation, minus 4. What it does is it translates, but up and down. Constant terms that are not in the power, not in the brackets, they're just sort of by themselves. They always shift a graph up and down, but they go in the way you would expect. So negative means down. So this will be 4 units down. But remember, it's also very important to know what this does to the asymptote. It is this number, this constant, by itself in an exponential that determines the asymptote. So when I say it's translated 4 units down, the asymptote of this graph would just be y equals minus 4, because you can't have 3 to the power of something equaling 0. This can't equal 0, so y can't equal 0 minus 4, which is negative 4. So that's all you needed to do, just list those transformations. So now let's go on to question 6. So in question 6, we're given here a parabola, and we're given a circle and asked whether they'd intersect. So if they would intersect, I should be able to substitute this one into this one and get a solution. So because y is x minus 3 squared, I can take my second equation, x squared plus y squared equals 1, and I can change y, rub it out, and replace it with x minus 3. So what you can do, the easiest way to understand, even though it takes a little while, is to try and solve this. So we'll start by expanding the brackets. So now we're going to collect like terms and get one side equal to 0. So now, we don't actually need to find the points of intersection, we just need to see if there are any solutions. So we just check the discriminant, so it's b squared minus 4 by a by c, so you get minus 28. So because that's less than 0, there are no solutions and thus no points of intersection. So let's now look at what this would look like on a graph. So I'm just going to draw a rough sketch. So x squared plus y squared equals 1 should be really easy for you. It's just 1 in each direction, and it forms a circle like this. Okay, so again, it's important to label your axis. So y equals x minus 3 squared, so it would have an x-intercept over here of 3. That would be its only intercept, and it would also be the turning point. And its y-intercept, if x equals 0, would be positive 9. So to be like up here, it'd go like this. So it wouldn't ever hit the circle, they never intersect. How easy is that? All right, let's do the final question, which is question 7. So we'll now go through question 7, which is quite a difficult question, so don't beat yourself up if you can't do it. So I own a canoe rental company, charge $12 per hire. At this price, I hire out 36 canoes per day. An industry journal says that for each increase of 50 cents on the price of the hire, I will have 2 fewer hires per day. So I want to find the maximum revenue I could make and what price I must charge in order to achieve this. So the question's asking about a maximum revenue. So we only know how to solve maximum and minimum problems using parabolas. So I'm at some point going to need to create a quadratic equation. That equation will be like the revenue equation, and I'm going to need to find its maximum. But I need to start, before I can do any of that, by defining a variable. So I need to let x equal something. Now this one's tricky because what we're looking at is the relationship between the number of customers and what happens as the price increases. X be the number of price increases. Now because the thing was talking about price increases of 50 cents, I'm going to let it be the number of 50-cent price increases. So let's look at what is happening, the relationship between the price and the number of customers. So at price of $12, I know I had 36 hires. I was just told that in the questions. The question's saying along the lines, if I have the price of $12.50, I will have 34 hires. A price of $13, I'll have 32, $13.50, I'll have 30, and so on. But also works in the other direction. So if I had $11.50, I would have 38 hires. So I've reduced the price by 50 cents. So I'm going to have 2 more hires. 11, I'd have 40 hires, and so on. So for $12 and 36 hires, x is 0. There's been no price increases. So here, for $12.50, I've added one lot of 50 cents. Here I've added 2. Here I've added 3. And then here I took away 50 cents. So x is like minus 1, and here it was minus 2. So you probably know by now to calculate the revenue, I just multiply the price by the number of hires. So what we can see is what is happening now, I'm getting $432. Now, as I keep increasing the price, what's actually happening is I'm getting less revenue because fewer people are coming. Now, if I decrease the price slightly, you can see that I'm actually getting a little more money than what I start with at $432. But that will reach a limit and stop. So, for example, if I had, x equals minus 10, if I reduced the price by 10 lots of 50 cents, $5, it would be 7. So I could expect that I would get 20 more customers. So it would be 7 times 56. But 7 times 56 is only 392, and that's less than what I started with. So somewhere between $7 and $12, there's going to be this sweet spot. There's going to be this price so that I'll get enough hires and I will make the most money. So that's what we're looking at here. So we know how we can write the price in terms of X. So I can just write the price as 12 plus 0.5 times the number of price increases. That's what the price will be. X is the number of 50-cent increases. Now I have to write the hires in terms of X. So when X is 0, I have 36 hires. So you can see when X is 1, I've subtracted 2. X is 2, I've subtracted 4. So the way I can link this number X in with the number of hires, it's just 36 minus 2 times the number of price increases. And that's what the question said. Each increase of 50 cents results in 2 fewer customers. So this is the price, this is the number of hires. So then if I let Y be the revenue, Y is just those things multiplied together. So if I expand this using FOIL, I get 432 minus 6x minus x squared. So all the hard work here was coming up with this revenue equation. Now that I've found the revenue equation, it's easy as. I know how to maximize it, I just find the turning point. So the x-coordinate of this turning point is minus b over 2 times a. So I actually get minus 3. So what this is saying is I will achieve the greatest revenue when I have 3 50-cent price decreases. That means the price will be 12 minus 3 times 50 or $10.50. So at this price, if X is minus 3, the number of hires that I will have is 36 minus 2 times minus 3, which is, of course, 42. So if I charge $10.50, I will have 42 hires per day, and I will make 10.5 times 42, which is $441. That's the maximum revenue. And that's exactly what I would have got if I substituted into this equation X equals minus 3. So the maximum revenue I'll make is $441 if I charge $10.50. So that was a very challenging question, but I know you guys are smart enough to do with it. So thank you so much for tuning in. I hope this helps you study for your test. You're a superstar. You're going to ace it. This has been the luckiest maths teacher in the world. Have a great day.